Is Tuesday, April 29th, and it's about that time of year when we start talking about the upcoming hurricane seasons in the East Pacific and the Atlantic. Now, first, when you see a video like this, something to understand is that forecasting hurricane seasons like this is still very much in its early phases in the field, and it's very hard to tell you exactly where a storm is going to form and is going to hit. Even 7 days out, it's impossible to tell you at this range months in advance. And the most important thing for you to do in this time frame before hurricane season and in the early season of hurricane season, before peak months, is to prepare for the hurricane season. Even if it's going to be a below average or an above average season, prepare the same way, because really it just takes one storm to make all the difference between a fairly inactive season and a historic season. Take 2022, for example. That was a below average season overall in relative to the overall activity that we had, yet we had Hurricanes Fiona and Hurricane Ian, very historic hurricanes for Canada and the US. So now we're going to start off with the global sea surface temperature patterns. We usually start off with this because the oceans can give you a lot of answers to the activity that you may see in the upcoming hurricane seasons, because if you look at the tropical latitudes of the world, most of these latitudes are water, and large-scale patterns that form in the oceans tend to last longer than they do in the atmosphere. And for that reason, patterns that form in spring and summer tend to persist into peak of hurricane season, and so the patterns that you see today, you can reasonably use to create a prediction for the hurricane season. Now, if we look across the Pacific, we have a bit of a different signal to what we've had over the past several years. We don't really have very strong signals of an El Nino nor a La Nina, and usually those are very easy predictors for Pacific and Atlantic hurricane season activity. El Ninos typically favor warm water out here, which enhances hurricane activity in the Pacific, suppresses hurricane activity in the Atlantic, and the La Nina has cold water relative to normal out here, suppressing the hurricane seasons out here in the Pacific and enhancing hurricane activity here in the Atlantic. But this year, we don't really have a strong signal of either taking shape. It's kind of this just end zone neutral look where we're not really El Nino nor La Nina, and this is forecast to persist. You can see this in the Enzo plumes from the European ensemble. This is showing you the forecast out through late October. This pink line that I just wrote here, this is the end of hurricane season, and the El Nino threshold is right about here. And you can see on the Enzo plumes from the European model, it's kind of just flirting with the El Nino threshold, but not getting there, kind of just warm, bias, neutral. And in fact, the European is the more warm solution out of this. A lot of other models are colder. You can kind of see this if we look at the Canadian ensemble or a climate model. You can see a colder bias neutral showing up here, and same with the North American ensemble, showing you this colder bias neutral showing up in the model. So we kind of just have, if you take the mean of all those, this enzo neutral signal that shows up in all of these. And this is not really helpful for determining hurricane season, because when you have El Nino not really present here or La Nina not really present here, other oceanic patterns can take hold and cause more wild card years for the Atlantic and the Pacific. I'll show you an example with the Atlantic with this map comparing two areas of oceanic waters. The first one is the Nino 3.4 region. This is this box that I'm highlighting out here in the Central Pacific. This is showing you, or this is how we gauge really where El Nino and La Nina has formed. And we also compare it to the Atlantic Meridional Moat, which is this area just about here, encompassing the Canary Current into the tropical Atlantic. And we compare this because these tell you a lot about each basin and how they're doing with their oceanic patterns. Like, for example, if you have cold here in Enzo 3.4, this can tell you that we have a La Nina here across the Pacific. And if you have warmer water here, this can be warmer tropical Atlantic. So I have a warm tropical Atlantic here, cold here. That's pretty much a guaranteed active Atlantic hurricane season, seen in the red dots on this graph, where you have, in the most part, active hurricane seasons. There's only two exceptions, 1970 and 2013, to that rule. Now, when they're both cold like this, we do have some uncertainty on exactly how a hurricane season may go. And for that, you're looking for the purple dots. And really, for an overall neutral year right now, I'll be looking at the yellow to purple dots, because we may still see, like the European ensemble shows, the Nino 3.4 region go warm. And you can see with these yellow and purple dots, we have a wide array of potential hurricane season activity ranges. We have 2003, 2004. These were very active hurricane seasons relative to normal. And if you look on the left side, we have years like 2015, 1987, 1983. These were very inactive years, though these were all more neutral years overall. And you can see this wide array of potential hurricane activity in this plot, showing you that this really is just uncertainty, what this brings us for these hurricane seasons. And we really don't have to look at this anymore. We just have to look for other oceanic patterns that are taking shape across the globe. One that you may pick out is that we have this very warm blob across the North Pacific. This is a negative PDO signature, which has been pretty persistent since about January 2020. And you can see this colder tongue of water, this colder horseshoe of water, moving along the west coast of North America. This is a negative PDO pattern, and in this type of a pattern, this does not favor the Pacific hurricane season because you have a lot of colder water coming down here into the regions that you would normally have hurricane activity during the peak of hurricane season. This can suppress further, especially if you have cold neutral like this, suppress hurricane activity. And one thing as well with this kind of a negative PDO signature, even if we do go warm bias neutral or weak El Nino, that would tend not to, if it's not a roaring El Nino, not fully suppress the Atlantic, especially with this negative PDO signature. And even if we get that, the Atlantic can still fight for some of the rising air. Now, the Atlantic signature is also kind of interesting this year. We have kind of this negative Atlantic tripole with colder water south of Greenland, warmer water near Bermuda, and colder water as well across the tropical Atlantic. This is a negative Atlantic tripole, more unfavorable for the hurricane season. And we've seen this before in years like 2013, 2014, where we had this kind of a pattern. And in those years, we had less active hurricane seasons as a result. Now, one thing we'll need to watch for is exactly how the tropical Atlantic persists into the summer months and into the fall. A lot of models are projecting that into May, we see a decrease in tropical or trade winds rather across the tropical Atlantic. And because of that, this water may begin to warm back up as we approach hurricane season. Now, exactly how warm this water gets, that's going to be important as well, because you can also see we have this warm water here in the subtropics east of Bermuda. And this does become important because this can disrupt the normal Hadley cell across the Atlantic. And the Hadley cell is where you have a lot of rising air in the form of thunderstorms across the tropical Atlantic. Normally rises here, and because of this, you need compensating sinking air, and it usually comes up north into the subtropics and sinks. But if you get warmer water here into the subtropics, you can kind of plot the average 26-degree isotherm during the peak of hurricane season. It looks somewhat like this. If you have warm water here, it kind of intersects this zone of warmer water in the subtropics more so than normal. And if you have warmer water here, you can get more thunderstorm activity across this part of the basin, enhancing rising air across this part of the basin. And you can then get compensating sinking air in the tropical Atlantic, which can then lead to tropical waves coming offshore, struggling because there's a lot of subsidence down here, sinking air, and then maybe they go on to develop further west, closer to land areas. And that is kind of a similar pattern that we're seeing to the climate model projections. This is the Canadian model showing you this warmer water than now across the tropical Atlantic, but we have a very warm blob sitting across the subtropical Atlantic, and a similar one in the North American model, where we have warm water sitting here in the subtropical Atlantic, and still warm west of Africa, but cooler than the subtropics here in this forecast. And so this is something to watch for hurricane activity in this year in the Atlantic. We don't have this roaring, strong, very record warm water in the tropical Atlantic this year. We have more of a mundane signal here that may be more inactive or less favorable rather for the hurricane season. Now, saying that, something to consider is that the Pacific is in general forecast to be in a favorable state for the Atlantic. We have this cold bias neutral showing up on a lot of these models. And like I said, even if this becomes, say, a warm bias neutral or weak El Nino, the Atlantic can still fight, especially if we get storms forming further west. And also, if we have this colder water in the East Pacific, we'll have to see how the Caribbean persists. You can see the NNME is showing a signal that may be a colder Caribbean than normal. The San Sips shows a completely opposite signal. But if this kind of a signal like the San Sips shows takes place, we may see a more favorable sign for Caribbean activity, where you have less activity in the East Pacific, more activity in the Caribbean, and that could be a case where you have, again, these tropical waves, they come offshore, they struggle, and then they come further west, and then they form closer to land, and then you have a close to home hurricane threat here. Now, these models only tell you so much, and we only trust them so much. There's, as you can tell from this, a lot of variance between how the patterns are changing on these models. So one thing we can do further to look at how hurricane season activity may be is look at historical analogs for the year. And so what I've done, it's a bit different than what I did last year. I first looked at years that were 2 years removed from an El Nino, because we had an El Nino in 2023, and also years that had similar Pacific configurations and Atlantic configurations to this year. And I got a wide array of years that I won't show you, but I got a wide array of years that I then compared to the end of winter pattern to North America, because the winter pattern across North America can often change the sea surface temperature pattern across the Atlantic, because for an example, this cold water is a result of a pattern that we had during the winter. We had a more low pressure across eastern Canada and western Greenland, more high pressure across the subtropical Atlantic, and this caused an increase in trade winds during the latter half of winter. You can see this if we look at the composite map of the end of winter. Focus on the red areas here. This is a high pressure relative to normal, enhancing those trade winds, cooling off the water anomalies that you can see there in the blue dotted contours there. Now, if we compare this to some years that were similar to the end of winter in 2025, we get a whole set of, I think it was 20 or 30 years that were similar to this end of winter pattern across North America and across the Atlantic. And what I've done is I've taken the intersection between the years that I found for the oceanic patterns and the end of winter patterns. And that gave me 6 analog years. You can see them here in this map: 2017, 1984, 1996, 1979, 2008, and 2011, that had similar finishes to the winter compared to 2025. And you can kind of see that we have this high pressure that may be extending a little bit further east here than shown across the Atlantic. And this may have increased the trade winds across the equatorial, or not the equatorial Atlantic, the tropical Atlantic. You can kind of see this contour here of cooler water off the coast of Africa as a result of those stronger trade winds that we likely saw in this end of winter pattern in these years. So now what you can do is you can look at the sea surface temperature anomaly plot for these years. And you may notice that some of these patterns are similar to how they progressed in the climate model predictions, where we have some warming in the tropical Atlantic, but we also have this warmer tongue of water in the subtropical Atlantic, a little bit warmer than the tropical Atlantic waters here. We also see this colder than normal signal showing up here in this end zone neutral signal in the Pacific with this cold PDO off the US West Coast. So what we can do now is we can look at all these years, which I've now put them in order, by the way, at the top here, 1996 being the best, 1979 being the worst. And we can look at all the hurricane activity that we had in those years. And we can plot this map, which shows you all the hurricanes and tropical storms that we had during that year. Now, this is a big bowl of spaghetti that is very hard to read and is not very useful just by itself, but it can be useful if you compare this to a hurricane track average. What I've done is I've created a hurricane track average from, I believe it's 1984 to 2020, showing you average hurricane tracks throughout the hurricane or the Atlantic Basin rather. And what you can do is compare all these analog years to that climatology, and then you get this map, which shows you the departure from that average of hurricane activity across the Atlantic. And you can see the distribution is heavily weighted to the west, likely a result of that subtropical warmth that we're seeing in these climate models and in current analysis, showing you a lot more activity off the US East Coast and near Bermuda. And we also see this signal in the tropical Atlantic of waves that may be coming offshore and not really strong signals of formation. We have some here, but it's not a very strong signal like further west, highlighting storms that may, or tropical waves that may come offshore, struggle because of more subsidence or dry air here, and then form further west and be a problem to areas like Bermuda, the Caribbean, US East Coast. And that's the general projection that I would expect for this hurricane season. And also with the subtropical warmth, you tend to get some more storms forming out here in the subtropics. They tend to go out to sea, but they can inflate tropical storm numbers, and that often can lead to threats to, say, Bermuda with that subtropical warmth. And you can also compare this to the East Pacific as well. You can see most of the hurricane tracks in these analogs are congregated near the coast of Mexico. Similar to last year, we didn't really have a lot of storms tracking out to sea last year. And this is probably what we're going to see again this year in the Pacific. So storms that may be forming offshore and tracking northwest, or forming offshore and coming into Mexico. That's what we can probably expect here in the East Pacific or Mexico. Now, for the Atlantic, I've produced some numbers for what I expect for the hurricane season. I've taken all these years and I've averaged them out, and I've looked at the percentiles of activity that we've had from these years. Some of these are very active years, some of these are very inactive years. And using those percentiles, I've gotten a range here like this for the hurricane season activity-wise, showing you 13 to 18 tropical storms, a fairly wide range, but like I mentioned, you can get a lot of tropical storms out here in the subtropical Atlantic, which can often inflate tropical storm numbers. But in terms of more quality of storms, less hurricanes, 6 to 9 hurricanes, 2 to 5 major hurricanes, which is below to above average in that range of hurricanes to major hurricanes. And you can also see the accumulated cyclone energy index, or the overall activity measure for the hurricane season, 90 to 140 units. That's about 90% to 140% of normal activity in the hurricane season. And I give this season kind of mixed odds here, but greatest odds of a near to above average season. And you can see all these averages compared to these numbers here in the averages from 1991 to 2020. Now, we will have to see how the Atlantic persists or changes into May, June, and July, and I will make updates to this forecast as we go in time. But as of right now, I think this is a good forecast, expecting something that is more average to above average for the hurricane season. Now, like I mentioned at the beginning, no matter if this turns out to be a below average season or a very active hurricane season, still need to prepare the same way, as just one storm can make all the difference for your hurricane season. And one example of this, 1979 is a analog here. It was a very inactive hurricane season overall, but one storm in particular that year was Hurricane David. That came roaring through the Caribbean as a Category 5 and hit Hispaniola directly. And that was a disaster for Hispaniola. Very bad hurricane, made that year historic just by that one storm, even though the rest of activity in that year really was not all too active. So that's my point, that even in a below average season like 1979, we can still have very significant impacts from hurricanes. And it is a reminder to always prepare as you would if the season was going to be above average, if it forecast to be a below average hurricane season. So that's all that I've got for today on this forecast. Like I said, I'll make updates to this forecast as we go throughout the coming months. But as of right now, this is what I feel comfortable forecasting for the upcoming hurricane season. NOAA will have their forecast coming out in May, and I may touch on that a little bit when it comes out. But until my next video, that's all for now. Thanks for watching.